Good afternoon, class. We are looking at pre-calculus practice test number 4, module 4, covering chapters 8 and 9 and section 5.4. 5.4, right triangle trigonometry, and chapter 8, the first part is application of trigonometry, the law of sine, the law of cosine, polar equations. Here's the second part. So I start with the angle of elevation and angle of depression and what they mean. Here's the definition. Angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. In other words, if you look up, in short, this angle is called the angle of elevation. Angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. So if you look down, in short. So always with respect to the horizontal line or horizontal plane. So you look up, angle of elevation, look down, angle of depression, and there are some other pictures. So the cat is looking up. This is the angle of elevation for the cat because this is the horizontal plane. And the bird, here's the horizontal plane. This would be the angle of depression. Or again, if a person is looking up for the plane, this is the angle of elevation, down for the dog, angle of depression. That's the concept. So having said that, let's look at this example. An aircraft is spotted by two observers who are 1,000 feet apart. As the airplane passes over the line joining them, each observer takes a siding of angle of elevation to the plane as indicated in the figure. How high is the plane? Either the figure must be given or you have to come up with that based on the given information. So here's the angle of elevation from the point of view of P, 40, from the point of view of Q is 35 degrees, and the distance between the two is 1,000. Now, how high is the plane? So we are interested in finding the height here. So first and foremost, we define our variables. This distance, let's call it y. The height, and that's what we are interested in, is h. Now, as you look at this triangle, 35 and 40 and some number, they must add up to 180. So the angle PRQ is 105 because it's 180 minus the sum of 40 and 35. That's how we arrive at this angle. So this is 40, this is 50, this one PRQ must be 105. What about this one? Well, if this is 90, this is 90, this is 40, they must add up to 90, so that's 50. If this is 35, they must add up to 90, so 90 minus 35. So we have 50 degrees and 55 degrees again. Just because these two must add up to 90 degrees. These two also must add up to 90 degrees. So very straightforward. And reminding you that sine law says sine A over A, sine B over B, and sine C over C are equal. Cosine law says A squared is B squared plus C squared minus 2BC cosine A. So with that being the case, we can look at the sine law. This is 105, and this is known. So we can say sine of 105 for over 1,000. And we can find y in a matter of sine 35 over y. So we're going to apply the sine law. So cross product means the product of these two is the same as this one. Y is the product of these two divided by sine of 105. And of course, sine of 35, sine of 105, both of them are uncommon, so you have to use a calculator. So you put it into a calculator, you calculate it with a couple of decimals. The distance PR becomes 593.81 feet. Now, if you look at this triangle, sine of 40 is the opposite. H over the hypotenuse y. H over y. And y, we found it. So H is the product of these two numbers. Cross product. And there you have it. H is 593.81 times sine 40. Put it into a calculator. 381.69 feet. Very straightforward. Two homes are located on the opposite side of a small hill. So there's a small hill, one on each side. To measure the distance between them, PQ is the distance. A surveyor walks a distance of 50 feet from house P, so it goes so many feet, in this case 50. To point R, uses a transit to measure the angle P or Q, so measures this angle, which is found to be 80 degrees. And then walks to house Q and notices the distance of 60. So we have this distance 50, this distance 60. We have the angle in between, the included angle as 80 degrees. How far apart are the houses? And we use the cosine law. So it's pretty much given. So in essence, we're going this way, 50 feet, creating an angle of 80 degrees, going this distance of 60 feet. So it's SAS, side angle side. We're going to use the cosine law. A squared is B squared plus C squared minus 2BC cosine A. This is what we want, PQ. So PQ squared is one side squared, 50 squared, plus 60 squared, minus 2 times the product of the two and the cosine of the included angle. So minus 2 times 60 times 50 times cosine of 80. So basically, put this into a calculator. Take a root, gives you PQ. So PQ is 5058.11 PQ squared. And PQ is the square root of that, which is about 71.12 feet. By the way, normally, if this is a whole number, we go by one more decimal. As far as the number of decimals, you always pay attention to what they ask you. And if you have doubts, put as many decimals as possible. If they say rounding, be careful. Two boats that are leaving the harbor in different directions make an angle of 135 degrees. So one is going this way, one is going that way, and that creates an angle between them, which is 135 degrees. One boat has traveled 300 feet, and the second traveled 350 feet. So that means if we call this A, B, C, one of them is 300, one of them is 350. This seems to be more. So this angle is 135 degrees. This has gone 300 and this has gone 350 feet. How far are these boats apart? So we just want this distance of BC or A. Why do we call it lowercase a? Because it's opposite the angle. So again, we have two sides, included angle. We use the cosine law, a squared equals b squared plus c squared minus 2bc cosine a, where in this case, a squared is, okay, so 300 squared plus 350 squared minus 2 times the product of these two numbers and cosine of 135. Just for the sake of argument, cosine of 135, it's the same as cosine of 45 degrees, but negative in the second quadrant because cosine is negative in the second quadrant, which is minus square root of 2 over 2. In other words, it's a common arc, but nevertheless, you have to put it into a calculator. So square this number, 2 times 300 times 350, and this becomes a plus, by the way, and we end up having this number as a squared, take a root, a becomes 600.83, about 601 roughly feet. It depends on how many decimals they ask you, okay? Two cars leave an intersection together traveling on courses with an angle of 45 degrees between them. If each travels 500 feet, how far apart are they? Similar to the previous question. So one goes this way, one goes that way. The angle is 45 degrees. Each one happened to be the same, 500 feet. And we use the cosine law again, okay, to find this missing side. Cosine law, a squared equals b squared plus c squared minus 2bc cosine a. So if we call this c, so it's a squared plus b squared minus 2ab a cosine c or cosine theta. It depends on, the takes that used. So 500 squared plus 500 squared minus 2 times 500 times 500 cosine of 45 degrees. Cosine of 45 degrees, it's a common arc and it's square root of 2 over 2. We know that, but ultimately, you need a calculator. You put it in, you take a root and see the distance that we want is 382.68 feet. Again, I can't emphasize this enough. The number of decimals, it depends on how they ask you. We're going to repeat the question. Two cars leave an intersection together traveling on courses with an angle, but a different angle. 30, instead of 45 degrees, now 30 degrees between them. And one goes 1,000 feet and the other one is 720. How far apart are they? So similar questions. One is going this way, one is going that way. The angle is 30 degrees. One is 720, one is 1,000. And what is the distance in between? So we use the same formula, the cosine law, and we say it's equal to 1,000 squared plus 720 squared minus 2 times 1,000 times 720 times cosine of 30 again. Cosine of 30 is also a common arc, but you have to put that into a calculator. Square root of 3 over 2. So you put it into a calculator and you evaluate it, it becomes 520.89, roughly 521 feet again. Pay attention to the way they want you to do the rounding, everybody. So these two questions very similar, just the numbers are different, okay? Conceptually, they both use the cosine law. Side, and they included an angle SAS, side angle side. Let me just write that. George is standing 35 feet in front of a house and notices that the angle of elevation from eye level to the top of the house is 60 degrees. Find the height of the house. Draw a diagram, reminding you again, here's the horizontal line. Angle of elevation if you look up, depression if you look down. So that's first the concept. So from the eyesight, looking up, making up the angle, which is 60 degrees, and 35 feet. The distance of 35 feet here, we are interested in finding the height. Now, easy way out, tan of 60 is h over 35, the opposite over the adjacent, and um, it makes h using the cross product 35 times tan of 60, which is again a common arc, but you have to use it. As square root of 3 is about 1.7. So you put it into a calculator, 60.62 feet roughly. All right, you're standing 27 feet in front of a house on a hill and notices that the angle of depression from eye level, the top of the house to its bottom is 73 degrees. Find the height of the house. Again, reminding you of the angle of elevation versus depression. So we're standing here from the eye level. Okay, first of all, this distance is 27 feet. And looking down, creating this angle of depression, which is 73 degrees. So that's 73 degrees. This is 27 feet, and we are interested in finding the height. Well, tan of 73 is the opposite, h over the adjacent 27. So h is the product of these two. So I hope you realize the importance of drawing. The drawing will help us define the variable and being able to come up with the equation to give us an answer. So h is the product of those two. It's not a common arc anyways. You have to put it into a calculator. 88.31 feet. That would be the answer to the question. So the height of the house is 88.131 feet. We are going to move on. Just to remind you what happens in short, and I'm going to go over that. You have two lines that are parallel and a line that crosses it. It creates many angles, okay? In fact, 8 angles. Some of them are equal. Some of them add up to 180, known as supplementary. That's it. Two parallel lines, AB and CD, intersected by the transversal line GH. The figure shows two parallel lines AB and CD intersected by the transversal line GH. Corresponding angles are equal if the transversal intersects at least two parallel lines. So corresponding interior angles, corresponding exterior angles. And so what happens is, as you look at this one, it has created, as I said, 8 angles. So 1 and 5 are equal, the pairs of corresponding angles in the given figure having the same color, okay? Or 1 and 5, okay, they are equal. 3 and 7, they are equal. 4 and 8, they are equal. 2 and 6 are equal. So corresponding interior angles found at the inner side of the intersection between the parallel lines and the transverse zone, what's inside. Corresponding exterior outside found at the outer side of the intersection between the parallel lines and the transverse. Alternate interior angles are equal, 4 and 6, for example. If you look at these two, okay, and the parallel line 4 and 6 are considered alternate interior. 3 and 5 are considered alternate interior. These are just terminologies, they are equal. Same side interior angles are supplementary. So if you look at the same side of this line, okay, you see that 2 and 3, for example, 6 and 7, 8 and 5, 4 and 1, they add up to 180. For example, 4, now that's on the same side. Now, as far as the interior is concerned, 4 and 5, they add up to 180, 3 and 6, they add up to 180. Alternate exterior angles are equal to 2 and 8. So this is exterior, so is this one. 1 and 7, 1 and 7. Same side exterior angles are supplementary angles 1 and 8. 180, 2 and 7. So in short, you have two lines that are parallel. A line that crosses it, known as transversal line, creates 8 angles. So we should know the relationship among those. So now, a balloon is flying at a height of 600 feet directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram, and of course, reminding everybody 1 mile is 5,280 feet. Draw the setting. So here's the balloon, okay, at the height of 600 feet above the Statue of Liberty. This is 600 feet. This is the airport. How far is it? 5 miles. This is the angle of depression, which is of interest to us. Because we're going to call it theta is a question mark. We are going to find it. And that is equal to this angle. We were just explaining this concept in the previous page. Alternate interior angles are equal. So we're going to find this, and that would be the answer to that. So with that being the case, obviously in this triangle, tan of theta is the opposite, 600 feet over the adjacent 5 miles. And we have to change one of them. It's easier to come up with the same units. It's easier to change this to 5 times 5,280 feet. They must have the same unit. So you put it into a calculator, you get 0.0227272. Notice I carry a lot of decimals just to be on the safe side. So what is this theta? Is tan inverse of this number. You put it into a calculator, gives you that. And if you want to stop, okay, if they told you how to do the rounding, you do it. If you're going to, let's say, round it here, so 1 changes to 2. So 1.302, because next to 1 is 9. 1.302 degrees. That would be the angle of depression. All right, so we discussed angle of elevation, depression, parallel lines, and now let's go to the concept of navigation and surveying. We want to remind everybody how that one works. A bearing is used to represent the direction of one point relative to another. Method 1. Direction or bearing of a point O to a point P equals the acute angle theta between ray OP and the vertical line through O, the north-south. Meaning, compare it to north or south, whatever is the closest angle. Okay, so that's the key. You want to make sure it's the closest angle and it's acute angle. Method 2, the direction or bearing of a point is the number of degrees in the angle measured in a clockwise this way. Direction from the north vertical line to the line joining the center of the compass with the point. In other words, the second one, just compare to north, only just mention the angle. So, for example, let's look at P1. We're going to go with both methods. Starting with method 1, the way the method 1 works, either north or south. Because this is closest to north, we're going to start with north. What is the angle? 30 degrees. Which way does it move? To the right. To the right is east. So north, 30 degrees east. Now P2 is here. Now this is closer to the north or south, closer to the south. So you have to go with south first. What is the angle? 50 degrees. Are we going east or west? So east is right, west is left. So south, 50 degrees west. That would be P sub 2. Now P sub 3 is here, obviously closer to the north than the south. So first you mention north, then you mention the angle 70 degrees, then the side which is east or west, the left side is west. So north, 70 degrees west. P4, closest to the north or south, obviously south, so you mention south first. What's the angle? 20 degrees. Right or left? Right means east. So south, 20 degrees east. Now let's go with the second method. This one, you just compare it. You just compare it to the north side. That's all. The angle in a clockwise. So obviously the first one is just 30 degrees. So that's the answer. And the method to this one is 30 degrees. These are all the angles that we have. P2 class, we go this way. Let me actually do the drawing. P2, just read this angle. Now, obviously, down here is 180. We add 50, becomes 230. Now, P3, we go this angle. Now, as you go all the way to here, see, 90, 180, okay, 270, add this much. Now, how much is this much? Since this is 70, you should know this is 20. So add 20 and you get 290 degrees. Let me erase my work so becomes clear. And now P4, you mentioned this angle. What is this angle? Up to here is 180, subtract 20, it's 160 degrees. That's how you come up with bearings, okay? Two different methods. A rocket takes off at a bearing of north, 30 degrees, east. East is this way. So you make up 30 degrees east. After flying, so again, reminding you of all of this that was mentioned from the previous page. So this is north, 30 degrees east, okay? It may not be to scale, but that's the concept. So we have that. After flying for 900 meters, so it goes in this direction, 900 meters, and heads northwest is this way. After flying 1,000 meters this way, what is the new bearing of the plane? Let's draw the diagram. First and foremost, I just wanted to make sure that we understand the bearing north 30 degrees east. How much do we go in this direction? 900 meters. Then we take a 90-degree angle, either going up or down. Because it says northwest, you go up. By how much? By 1,000 meters. So this is 90 degrees. What is the newest bearing? Well, let's connect them. So what is the new? Okay, so let's call this angle alpha. If this angle is alpha, we are going north, alpha, west. So all we have to do, figure out what is the value of alpha, and we are home free. Right? You have to figure out what is the value of alpha. So how do we do that? It's very simple. We're going to call this angle theta. And this was north 30 degrees east. That means this angle was 30 degrees to begin with. So what is alpha? Theta minus 30 degrees. Which means if I can find theta, I'm practically done. Now notice here is 90 degrees in this triangular shape. Tan of theta is the opposite, which is 1,000, over the adjacent, which is 900. So tan of theta in this triangular shape is the opposite 1,000 over the adjacent 900, or 10 over 9. So theta is tan inverse of 10 over 9. You put it into a calculator, you get 48.0127, whatever. And let's say if you stop here, the next one is 2, so it doesn't change, 48.01 degrees. So now, what is alpha? This number minus 30 degrees, which makes it 18.01 degrees. And so you're going to say north 18.01 degrees west. That's the final answer, everybody. So the concept of a bearing is used here to solve a problem. An aircraft leaves an airport from a runway with a bearing of north, 40 degrees east. So north, east. So over here, you make up a 40 degrees. So the very first thing is north, 40 degrees east means in this direction. Okay, that's the meaning. After flying for half a mile. So we're going to go half a mile in this direction. The pilot turns 90 degrees. So when we turn 90 degrees, okay, we go either up or down. Okay, this is a 90 degree. And heads towards southeast. That means we are going down. So it's going to go this way, north 40 degrees east for half a mile. Then we're going to turn 90 degrees and head towards southeast. And we're going to go for 1 mile. So this is a 90 degree and this is 1 mile. After flying for 1 mile in this direction, what bearing should the control tower use to locate aircraft? Draw a diagram. So we have the diagram. So let's do the drawing. So this is where the aircraft is heading. So if we have this angle, let's call this angle alpha. Then the aircraft is going south alpha east. So the aircraft is going south alpha east, south alpha east. So all we have to do, come up with the value of alpha and we are done. Notice this is 180 degrees, so 40 degrees, and this green angle and this red angle, okay, the green one, we're going to call it theta. 40 and theta and alpha, they add up to 180. Again, this is 180. This we know it to be 40. This is, we give it the name theta, and this one is what we are looking. So the sum of the three is 180. And since we know this one, all we have to do, come up with theta. And in this right triangle, we can easily find theta because tan of theta is the opposite, which is 1 mile, over the adjacent, which is 1/2. So in this triangular shape, tan of theta is 1 over 1/2 or 2. Therefore, theta is tan inverse of 2. And tan inverse of 2, when you put it into a calculator, results in 63.43 degrees. So if I replace it here, add it with 40, subtract it from 180, I get alpha. So alpha is 180 minus the sum of 40 and the value we just found for theta, which is 63.43. So this is 103. 0.43, subtracted from 180, we get 76.57. Therefore, the bearing is south 76.57 degrees east. Very straightforward.